Okay, we've done a little bit with gates, and up until this point, gates give us an instantaneous snapshot of what's going on with the logic inside of a circuit. And that's all well and good, but sometimes we need to take into consideration things that have happened in the past. So without having some sort of memory, then we're not really going to be able to do too much. But I promised you with those ands, ors, and nots that we could make anything. And so today what we're going to do is we're going to make a 1-bit memory location so we can store what happened before so we can come back and use it again. Okay? And this is going to make it so that we can make sequential things happen throughout time. And it's the basis of all of the computer memory that we use. So we're going to use NAND gates, which I'm going to prove that you can make a NAND gate out of ands and nots, and then we're going to go from there. Okay? So, all right. We're going to look at the NAND gate. Okay? It looks like an AND gate with a little circle on the end to represent an inversion. And all a NAND gate is the opposite, the inverted output of an AND gate. Okay? So an AND gate looks like this on a truth table, that the only time it's true is when both of the inputs are true. A NAND gate, so that's an AND, let's put that right there. A NAND is going to be the inversion of that. Okay? Now, one of the things that we're going to hit up on is if we can build everything with ands, ors, and nots, that's all well and good. But a NAND gate, we can actually build everything off of nothing but NAND gates. But a NAND gate is not a Genesis type gate. You have to have 2 gates to make a NAND gate. You have to have an AND gate and a NOT. But with those together, we use it so often that we've got a specific symbol for it. The NAND gate is also a Genesis type component. Well, I wouldn't say Genesis because it's got an AND and a NOT, but we can build all logic with NAND gates. And when you look at your flash RAM and your solid state devices, like your solid state drives, they usually will say something about NAND technology because that's what they are. It's just millions of NAND gates that are reconfigured as needed. All right, so get used to this because we're going to use it a lot. A NAND gate is the opposite of an AND gate, and we're going to do a bunch with it. Okay, so what we'd like to do is with normal gates, if we put a 1 here, we'll get a 0 out here. But if this changes, this will change too. So there's no way of storing information to come back and see what happened later. All right, so what we're going to build today is, let's call it a set, reset, latch. Okay? This is going to operate a little bit different than what we've seen so far. So if we take 2 NAND gates, and we take the output of one NAND gate and put it into one of the inputs of another NAND gate, and then we take the output of that NAND gate and put it in there, we get some feedback going on. Okay? And that feedback is going to help us keep things in a certain spot while things in front of it are moving. Okay, so anytime you're presented with a circuit, a good thing to do would be to make out a truth table for that circuit. Okay, so traditionally we'll call the outputs of a latch Q and Q naught. Okay, so if this is 1, we want a 0 out of here. If this is 0, we want a 1 out of here. Okay, so let's go through and we'll call this our set and our reset. Okay, so we've got 2 different inputs, 2 different outputs, and let's see what's going to happen when we put these inputs in. Okay, so we're going to take 0, 0. All right, if 0 is on one of our inputs, so let's say we've got 0 here and 0 here. We can't really tell what, that's not enough information yet, right? So on one of our NAND gates, we got a 0. On the other NAND gate, we got a 0. Okay. Let's look at those cases where we've got a 1. Okay. So if actually think about this. Let's go back to that 0, 0. This does give us some information. If we've got a 0 on any of those inputs, like if we've got a 0 on either one of these inputs on this one, this output is going to be a 1. So since we've got a 0 over here, we're going to have a 1 right there. So we've got a 1 on the output of both, right? Because anytime we see a 0 on an AND gate, we get a 1 out. Okay, so in this case, we're going to say this is garbage. So we're going to say this is an invalid condition. Okay, so if we have 0, 0, then we're going to have 1 out on each one of those NAND gates. Okay, because if we have a 0 on either one of those inputs, we get a 1 out. Don't look at it as S being 1 and the R being the other. Like, just look here. In this gate, if there's a 0, we look back up here on the NAND gate, and we're going to get a 1 out. So if both of those are 0, then both those outputs are going to be 0 and are going to be 1, and that's going to be garbage. Okay? Because Q and Q not need to be opposite. And in this particular case, they're not going to be. Okay? All right. So now we've got 0 and 1. When we've got 1 on a gate, then we have to look at what the other gate is doing. So we're going to put a 1 right here. And up here, since that S has a 0, that's got a 1. So we got a 1 and a 1 on a NAND gate, right? Which is going to make this 0, which makes this input 0. So we got 0, 0 up there. We've got a 1 on the Q, and we've got a 0 on the not Q. All right, so we're doing pretty good. All right, now let's change that. Now we've got 0 down here, and we've got 1 up here. Okay? So if we've got 0 down on the bottom, we know we've got a 1 on the Q naught. And if we got a 1 on the Q naught, we've got a 1 up here on the second terminal of that NAND gate. So we've got a 1 and a 1, so we're going to have a 0 there. That checks out. And then this should be 1, 1. Now, 0, 0 gives us a problem because we got 1 out on both. Okay? Let me erase a few of these so that we don't get too confused. What the 1, 1 does is it latches things in. Okay? So when we do a 1, 1, it's going to keep the output staying the same. Okay? So if we had a 1 and a 0, okay, that means that we had a 0 up here and a 1 up here. Now look what happens when I change that 0 to a 1. If I change that 0 to a 1, now I've got a 0, 1 down here, which is still a 1. That 1 and 1 up there, no change, right? If I had it the opposite way, so I had a 0, 1 like this, I'm going to have a 1 in the Q and a 0 in the Q naught. And then I change this to a 1. That's a 1 and a 0. That's still going to be a 1. And that's going to be a 1 and a 0, or a 1 and a 1. And that's going to be a 0. So right here, we're going to say no change. And so what we're doing is we're building a latch. Okay? All right. So let's build that. We're going to go to our NAND gates. That's an OR. That's an AND. We're going to take a 2-input NAND gate. We're going to put it there and there. We're going to take 2 input switches. Put it here. We're going to call this set. We're going to call this one reset. We're going to take our wire. We're going to go from the output of this one down a little bit. Down a little bit more. And we're going to crisscross over to the input of here. I'm going to take this. We're going to take this input. Garbage. My computer's acting up a little bit. So it's laggy, so I'm not getting the lines as quick as I want them to be. See. And then I'm going to go over here and let's take our test LEDs. We're going to output them here and output them here. Then we're going to right click so that wire goes away, and then we're going to run it. And let's save this as SR underscore latch. Okay, so those Q's should never be on at the same time, and they are. So we're going to say, if this case is a situation that's invalid, throw it out. So maybe later we'll make it so that they can't be on at the same time. Okay? All right, so if we've got the set and let's do 0, 1. So we're going to do 0 and a reset of 1. All right. Now we've got 1, 0 up here. Okay. That satisfies our Q and Q not being inverses of each other. Now what happens whenever I go and peg this on? It doesn't change anything, right? So now I could save this in memory. All right. Now we're going to make a few little adjustments to make this a little bit easier. But all right. And then So we turn this one off. So we got 1, 0. Now we're getting 0, 1 out here. So it's really we would call this like the Q naught and this the Q. Okay. So when we set it, we set the Q as being high. Okay. Now, what if we wanted to enable when this was going to happen? Okay, so let's go and stop this. All right, and let's move this over. And then let's take 2 of our AND gates. All right. And then we're going to take another input switch and put it right here. We're going to call this enable. All right, sorry. Let's take this, move it over here. Let's take this set and move it over here. All right. Now, watch the magic here. This should be pretty interesting for some of you. All right, so if we put an enable switch here, and we know how an AND gate works, like if 0 is on the enable, then neither one of these gates will let stuff through. We could have 100 AND gates all tied up with one of their legs to an enable, and if that enable is 0, then nothing gets through those gates. So that should start helping you realize that we could control the flow of information pretty easily. Okay? So we're not going to let things through unless that enable's on. And we'll prove that in a second. Sorry it's not as pretty as it normally is. I've got some lag. So it's hard for me to... Alright, so this is an SR latch. And with it unenabled... Alright. Now we're letting stuff through, so those zeros are going. So if I set it, let's say that this is Q down here and this is Q not up here, then our set will be on. And then I could enable or unenable it. We've got some garbage data there, but let's set this and we'll turn that back on. Alright, so with it enabled, we're able to change things over, and when we disable it, we don't. All right, so now with that set and reset really needing to be inverses of each other. Instead of having to flip back and forth on things, what we could do, let's go ahead and delete this set and this reset. And we're going to call the new switch data. Okay? And if we know that the other input needs to be the opposite of it, then we could put an inverter there so that just with one switch we can take care of both those inputs. Okay? So I'm going to do a Control W to make this a little bit easier. Right click to delete, or to stop the line. And then do that. And then we're going to play. And what we've got here is a data latch. Okay? So without being enabled, this isn't doing anything. But as soon as I enable it, I can start setting and resetting my data. Okay? Now, when I disable it, nothing happens up here, so I can choose when to put data in here. Okay? It's super powerful, really. Like, let me pull up. Let me see if I can pull up something for you. So I enable it. Wrong. I'm going to set through there, and then it's going to latch. Pull those both. So, alright. So this is the beginning of being able to save things in memory. Like, if that's not enabled, it's not taking anything through here. Okay? So, I want y'all to read in that chapter to try to get a better understanding of this, but we're going to use this a lot. Okay, let's see if it doesn't work with what you expect from what the book says. Okay. All right. So that is making a 1-bit memory, and we'll build off of that as we move forward.